Hi everyone, it's Mrs. Burke. Today I'm going to teach you about unit rates. The first problem that we're going to start with is comparing some creamy, skippy peanut butter in two different sized jars. The first one has a jar with 16 ounces and it costs $3.20. The other jar is a larger jar that has 64 ounces in it and costs $9.60. Like you to pause the video and see if you can figure out which jar of peanut butter is a better buy, meaning it's going to be cheaper or cost less per ounce of peanut butter. Think about ratios and the order of those words that I just said or that are written on the packet to help you figure out which one is going to be more cost effective. Now that you've had a chance to try this problem on your own or with a partner, we are going to go through it together. The first small jar that has 16 ounces for $3.20, we can write as a ratio of money, $3.20, to ounces, 16 ounces. Or we could also write it as a ratio of ounces, OZ stands for ounces, to money, $3.20. Now, when we're comparing the other jar to that one, we want to make sure that whatever ratio we write it in the same order as we wrote the original ratio for the small jar. So the large jar, if we started with money per ounce, we want to start with $9.60 on top for 64 ounces on the bottom. Or if you did it the other way, 64 ounces on top for the $9.60 on the bottom. Now we have some couple of different options from here. We can use that trick of cross multiplying up to find a common denominator and then be able to compare the numerators. Or we can also look at it as a fraction, and we know that a fraction shows division. So if we take the $3.20 and divide it by 16 ounces, that will give us 0.2 or 20 cents per ounce. That means each of the ounces in the small jar will cost 20 cents if we were able to pull them apart. In the large jar, if we divide the $9.60 by the 64 ounces on our calculator, we'll get 0.15 or 15 cents per ounce. This will tell us very clearly that in each of the ounces in the large jar will cost 15 cents, which means that would be much cheaper than buying it in the small jar. Now, if we use the other ratios and compare the ounces to money, 16 divided by 3.2 or $3.20 will tell us that we can buy 5 ounces per $1. So if we walked into the grocery store and said, I have $1 for the small jar, we would be able to buy 5 of those ounces. But for the large jar, if we were going by that, we would be able to buy 6.66 repeating ounces per $1, which again confirms that the large peanut butter jar is going to be a better buy. What's most useful and what grocery stores use is the first ratio. These are called unit prices, and these are on unit price stickers or price stickers at any grocery store. I want you to look out for them the next time you go there. If we flip to the next page, first thing we want to do is figure out some unit rates that you have seen or heard of before. Let's remind ourselves what a unit rate is. A unit rate is a special kind of rate where you can compare a certain quantity of a unit to one quantity of another unit. And a lot of times they will use the word per, each, or every. And that will imply that it's out of one. For example, you might have heard of miles per hour, or MPH. It's the abbreviation. That tells us if someone is driving 45 miles per hour, they can drive 45 miles in 1 hour continuously if they do not stop. Also, you might have heard of words per minute. That is how many words, if you continuously typed at that same rate, that you would be able to type in 1 minute. Other ones you might have heard of are price or money per hour. If you get a job, this is typically how you are paid, or by salary, amount of money per year. You also might have heard of money per some unit of measurement that's a weight, for example, pound or ounces or liters or fluid ounces. And this is the one that is used all the time in grocery stores. Now, why are they helpful? Because it gives us a specific unit rate out of one, and it also helps us to compare things easier. If someone is typing 45 words per minute and someone else is typing 50 words per minute, it's much easier to compare than us saying they typed 1,000 words in 30 minutes and someone else typed 1,200 words in 45 minutes. If we have their unit rate, it's much easier to compare which one was typing faster and or slower. Let's try some problems. Georgia works at Joey Garlic's Pizza and made $375 in 25 hours of work. Find the unit rate or the amount of money she makes per hour. The order of the words will help you determine what order to divide the numbers in. Again, she worked for 25 hours and made $375. So if we follow the order of the words given in the question, we are going to divide the $375, the money, divided by the hours, the 25 hours. When we use our calculator and do that calculation, we should get $15, which means she made $15 for each hour that she worked, or $15 per hour. We can also use equal ratios like we have in the past to either double check or also to solve the same problem. We again want to make sure that the same units of measure go in the same spot of the ratios. So for example, if we do the $375, we need to make sure that the dollars go in the same position in the other ratio. And the 25 hours, the hours go in the same position in the other ratio. Now this time we're finding it how much it is out of 1 hour and how much money that she would be making out of that 1 hour. We can use the scaling method and multiply 1 times 25 to get the 25, and then look at how much times 25 will get us 375, or we can cross multiply and divide to find out that unknown value as well. When we divide 375 divided by 25, we will still get the same $15 per hour, which makes sense because $15 per hour is the minimum wage in Connecticut. Let's try another one that has us compare two different people and their speeds. The first person is Brooke, and she is driving 300 miles in 5 hours. William drove 280 miles in 4 hours. What is each person's speed in miles per hour? Again, The order of the words will help us to determine what order to divide in. So for Brooke, if she drove 300 miles in 5 hours, we would divide the 300, because it is the miles, divided by the hours, the 5 hours. And we would get that she drove 60 miles per hour, which is what the MPH stands for. William, on the other hand, drove 280 miles in 4 hours. And I'm dividing again the miles divided by hours, not because the order is given, it's given in that order in the words, but because the question, the order of the words in the question, tell us to divide the miles per the hour. And when I divide 280 divided by 4, we get that William was driving 70 miles per hour. Now we can easily compare and say Brooke was driving slower than William. I'd like you to continue working on these problems using unit rates. Again, please pay attention to the order of the words. For example, in number 5, it says cost per pound. That should help you determine that you should be doing the money divided by the pounds to help you figure out how much the different meats will cost per pound. If you need help, please check the answer key for some tips or look at Khan Academy. Have a great day.